Hello everyone, welcome to my chemistry channel BL Das, short and sweet in chemistry. Now I am going to explain the topic numerical application in chemical kinetics. Now it is our that is introduction part 5. In introduction part 5, I am going to explain half-life reaction, half-life of a reaction that is called half-life period. Then what is half-life period or time? That is time in which the concentration of the reactant is reduced to half of the initial concentration. If R0, R molar concentration 0, if it is initial concentration, see this is the initial concentration, then it reduced to half. So at a time t, then what happened at time t? If it changes to t half, that means R changes to R0 by 2. That means initial concentration divided by 2. For 0 order, how many order are there? You know till now. For 0 order, first order and second order. 0 order, first order, that are very important. So for 0 order, here what is the half-life period? How can you calculate half-life period? K equal to R0 minus half R0. That means here the final is R half R0. So what is the meaning here? T, this is for T half. Remember this equation for T half. Then before that, what is that one? That is R0 minus R. K equal to R0 minus R. But what is R here? This R equal to R0 by 2. So put the value here, then what you will get? That is R0 by 2K. After calculation, you will get here R0, R molar concentration 0, that is initial concentration, divided by 2K. So this is the formula you should remember. For first order half-life period, you know for the first order, what is the equation? K equal to 2.303 T log R0 by R. So here what to do? How to calculate T half? The time changes to T half. Then what is the value? R changes to R0 by 2. That means where there is R, just like here, you put R0 by 2. After cancelling each other, then you will find here 2.303 by T half into log 2. You should put the value of log 2 here and calculate easily. So again see, R equal to R0 by 2. You put the value here and after calculation it comes to K equal to 2.303 by T half into log 2. What is the value of log 2? You put the value of log 2, 0.301, and multiplying the 2.303 and here 0.301, then it comes to 0.693. 0.693. Then it is the T half equal to 0.693 by K. So after multiplying 2.303 into 0.301, the value comes to as 0.693, and this is K is there, and so put the value K. So 0.693 by K. What is K? Rate constant. What is the rate constant? First order rate constant. Half-life period for the second order. Similarly, you will calculate second order. First you put the formula that is second order equation. So KT equal to 1 by R minus 1 by R0. What is R0? Initial concentration. What is R? Final concentration. Now since T changes to T half, so this R changes to R0 by 2. So you put the value, and after calculation you see this is the answer KT half equal to 2 by R0 minus 1 by R0. Molar concentration. You should put the molar concentration sign. That means 2 by R0 molar concentration. Here R0 molar concentration 1 by. That means what is R0? Initial concentration. So T half equal to, after calculation, you remember this value, this formula, that is not so important, but fast and zero order very important, but for competitive exam it is maybe important. So 1 by K R 0. So if you see zero order, one first order, second order, third order, if you go to last May, what is the n half lives? What is the n half lives? 1 half life, 2 half, and similarly n half lives of first order reaction. How many orders you follow here? Zero order, first order, second order. Zero order, first orders are important. And for first order you will see if there are n half life period, what is the substance left? What the amount of substance left after n half lives? See, this is the formula. This is the formula you should remember. R0 2 to the power R0 divided by 2 to the power n. Again remember R0 molar concentration, that means initial concentration of the reactant divided by 2 to the power n. What is n? N is the number of half lives. That means if you put this value, you get that amount of substance left. Then come to time required to reduce concentration. Here you will see the in detail. Time required. Here what is that one? After n half lives, what is the substance left behind? This one. After this substance here left behind. After the n half lives, the substance left behind. And here you will see just opposite. Here you will see time required to reduce to any fraction of initial concentration. Just now I have explained T half. Similarly, T 1 by 3, 1 by 4, 1 by 5, like this you will put the value, and what you will get, what is the general formula for a general reaction. The time required to complete 1 by 3 of the reaction. 1 by 3 means 1/3 of the reaction. Then R0 equal to A. Let you put R0, that means R initial concentration, that is why R0, and having molar concentration sign. If the value A, then R equal to how much? A minus A by 3. Initial concentration A, and that is how many reactant, that one? Minus A by 3. A by 3. So what is the answer? 2 by 3A. What is value? 2 by 3A. Then what is the initial concentration? A. And after 1/3 of the reaction, and what is the final concentration? This one. What is the final concentration? This one. See. So this is the final concentration. This is the initial concentration. Then you can calculate easily. T1 by 3. See, the question is 1/3 of time. 1 by 3, just you know 1 by 2, half. Here 1 by 3, 1/3. Then what is the that is formula? K 2.303 divided by K log initial concentration divided by final concentration. So what is the initial concentration? You put here A, and what is the final concentration? You put 2 by 3A. Cancel each other, and last what is the value? Log 3 by 2. You put the value of log 3 minus log 2, then it is the answer. Similarly, if we say 3 by 4th of the reaction, 3 by 4 means 3 by 4, here what will the initial, what is the final? Let R0, here what is the value? Let R0 value, that is A, small a. Okay. Then R means 3 by 4, this should not be 3 by 4 minus a. This is a minus this should be a minus 3 by 4. So you will get here 1 by 4a. 4a minus 3a equal to 1 by 4a. So instead of here 1/3, it is 3 by 4. So value is 1 by 4a. So t 3 by 4, you put the value and then come to log 4. That means here 2.303 divided by k log 4. So again see log a by 1 by 4a, and that changes to log 4, and the total value that is changes to 2.303 by k log 4. So you put the value of log 4, then you get the answer. Similarly, for a complete n fraction, just now I told here 1 by 2, 1 by 3, 3 by 4, like this. Here you will see nth fraction. N fraction means what to do? R0, what is the value here? R0 equal to a small a, remember. And final concentration, R0 is the initial concentration and R equal to final concentration. Then you put the value a minus a by n. What is the value? Here you will take a is common, 1 minus 1 by n. So what is the equation then? Then t 1 by n, that is n fraction, and here 2.303 by k log the initial constant how much? A. Final constant how much? A multiplied by 1 minus 1 by n. A bracket 1 minus 1 by n. You put all the value. Then ty by n equal to, here you write correctly 2.303 by k log a bracket 1 minus 1 by n. What is n? N is the fraction. So here conclusion you can say half-life period for different order. That means 0 order, how the t half varied? T half varied to initial concentration in moles per liter. And similarly for 0 order, that is T half proportional to R0. So T half equal to how much? K is a constant, that is rate constant. So for 0 order it should be 0 order rate constant. For first order it should be first order rate constant. The rate constant that depends on the order of the reaction. For 0 order, what is the value? That one T half equal to K, that is initial concentration of reactant. For first order, and here you know T half proportional to R0, that is initial concentration to the power 0. Anything power to 0 means 1. If you take a constant, then T half equal to K. Here K is the first order constant. Here it is the first order constant, and here it is the 0 order constant. Similarly, second order, what is the value? T half proportional to R initial concentration, that is R0, to the power minus 1. So what is the value then? T half equal to K 1 by R0 means initial concentration. If you see, this is the in the order where you are getting T half value for 0 order, first order and second order. This is the serial one. By looking this, you can put the value nth order. Nth order means here T half proportional to R0, here to the power 1 minus n. Here 1 minus n, then here if you take to proportional, then what is the value? T half proportional to, if you take n minus 1, then what to do? Then proportional to 1 by R, that is initial concentration, power to n minus 1. So remember, for the 0 order, T half equal to K initial concentration, and first order T half equal to only K, that is independent of the initial concentration. So looking this formula, we will see the graph. We put the graph, plotted the graph, then what is the graphs happening here? Half-life period method very much useful in graph to predict the order of reaction. If you know the T half, then concentration of any reactant, then you can find whether it is 0 or first or second order. Now see, T half proportional to R, that means initial concentration for 0 order, proportional to initial concentration having power 0, and concentration proportional to R initial concentration minus 1 for second order. Again see, if T half proportional to initial concentration 0 order, if T half proportional to initial concentration having 0 power first order, if T half proportional to initial concentration minus 1, power minus 1, then for the second order. In general, you can write T half proportional to 1 by R initial concentration to the power n minus 1. Okay, then you will see the graphs. For 0 order, according to the equation, you can draw the graph. T half equal to initial concentration of the reactant, then versus T half versus initial concentration is plotted. A linear line, straight line, which passes through the origin. See, this is the origin part. You will see here, this is straight line and slope equal to K, and this is the 0 order. Suppose you know the values of T half and R0 at different time, then you draw the graph and the graph looks like this, then you are sure that it is the 0 order. Then you will go to first order. For first order, it is the formula T half equal to K, that is, it is independent of the initial concentration. Just now I told T half K initial concentration of the reactant power to 0, that value equal to 1. So T half is independent of the initial, T half always independent of the initial concentration of reactant. You should write reactant, otherwise it is not correct. So if you plot T half and R0, that is initial concentration, you will get a parallel line which is drawn to R0. If which is parallel to R0, which is parallel line which is drawn to R0. Here this is the parallel line and it is parallel to R0, and x-axis, that is, it is your x-axis, that is x-axis, and this is your y-axis. This is for first order. Then come to second order. T half equal to 1 by R, that means initial concentration, that is R0 with molar concentration sign. The plot, if you plot the T half versus 1 by R0, sorry, it is 1 by, it is not R0, simply it is not R0, it is 1 by, that is initial concentration. So you should write 1 by R0. So see, if the graph is a straight line passing through the origin and between T half and 1 by R0, then it is your sure, it is your second order reaction, and with slope is K. So it is clear. So here in second order you will draw a graph between T half and 1 by R0 initial concentration of the reactant. You will get a straight line. In here then you will calculate the amount of reactant n half-life. Just before also I told, again I am going to conclusion here. Amount of reactant n half-lives, n equal to 1, n equal to 2, n equal to 3, then what is the answer? So see, if n equal to 1, initial concentration divided by 2, and if 2 half-lives, then what to do? Half 2, that means 2 to the power square. If n equal to 3, 2 to the power 3, that means you will calculate here the amount of reactants left behind, also I told before. Then here, if n half-lives, that is the formula, initial concentration of the reactant divided by 2 to the power n. So T half, for T half, how can remember? This is also your summary conclusion order. If it's 0 order, then rate is like this. If first order, the rate is like this. And rate for 0 order, rate is K R2, R mean here to the power 0. If first order, here R to the power 1. Similarly, second order rate K R to the molar concentration of the reactant power 2. Again see, for 0 order rate equal to K R mean concentration of the reactant to the power 0. If first order rate equal to K R, that is molar concentration of reactant power 1, and second order the rate K molar concentration of the reactant to the power 2. So when you come to T half, this is the value for 0 order and first order, then second order. I hope it is clear to you about our half-life period or the time required to reduce in that initial concentration to half. And thanks for watching my video, and thanks again. I am Mrs. B.L. Das, ex-PGT Chemistry, Kendra Vidyalaya Sangathan. Thanks again to all.